Hello and welcome to today's IWCS webinar. My name is Connie and I'll be your Cisco WebEx producer for today's event. Now I am pleased to turn the webinar over to Ed Fenton, your IWCS moderator. Ed, please go ahead.
Thank you, Connie. Our IWCS webinar series event is hosted by the International Cable and Connectivity Symposium. I am Ed Fenton, a cable industry advisor working with the IWCS team. As Connie said, if you have questions, please use the Q&A box on the bottom right of your screen to post a question anonymously. If you wish to contact the presenter or IWCS after the presentation, you will be given the contact points at the end of the webinar. Please note that IWCS does not distribute the presentation slides from either our conference sessions or these webinars. However, please feel free to contact the presenter directly and they will respond individually to you. Today we welcome Ehsan Fallahmohammadi, Innovation Lead, Prysmian Group, North America and South Carolina, United States, who will be presenting his paper on ultra-high fiber count cable designs with structurally and environmentally robust flexible ribbons. Ehsan Fallahmohammadi is the innovation lead at Prysmian Group North America. He obtained his bachelor's degree in chemical engineering and master's and PhD in materials engineering from Polytechnic University of Milan, Italy. He has 5 years experience in Prysmian Group, and he is the inventor of more than 10 international patents in cable industries, as well as the author of more than 20 international scientific journal and conference papers. Ehsan, we welcome you to present at today's IWCS webinar series event.
Thank you, Ed, for this opportunity. Hi, everyone. Thank you for the opportunity to present these two papers that get a lot of attention at IWCS last year, and specifically in this webinar, which is give us an opportunity to present it to a much broader audience today. As Ed mentioned, my name is Ehsan Fallahmohammadi, and I'm the innovation lead in Prysmian Group North America. I have to mention that a lot of work that has been done here is not my work, and there are other co-authors and many other people and engineers done a great job on this to be on this point. I want to acknowledge here my colleagues and my co-authors of this paper, Mr. John Satch, Senior Product Development Manager, Mr. Jeff Parker, Director of Research and Development, Mr. Brian Rich, Material Technology Manager, who presented actually originally this paper at IWCS, and also our engineering team, Ben Wells, Nick Anderson, Andrea Terry, Gavin Lynn, and everybody who contributed to this project from the beginning to now. All right, so I'm going to start. As the title says, this paper describes a new design for an ultra-high-density optical fiber cable with FlexRibbon, structurally environmentally robust. And I'm going to go through the outline quickly. The outline is, of this presentation is going to be an introduction to UHFC ultra-high fiber count cable. And then I'm going to talk about our, the current rollable ribbon design. And then we're going to discuss about the new FlexRibbon design of Prysmian. And then we're going to talk about the mass fusion splicing 200 and 250 micron, and the robustness and material handling of the FlexRibbon, as well as the in the other section, FlexRibbon in the ribbon and loose tube cable design. And I'm going to cover also qualification test result as well as the lastly conclusion. And at the end, I will take a question, and we'll be glad to answer the questions. All right, let's start with the very brief introduction to ultra-high fiber count cable. I'm not going to give you any lessons or anything on that because there are lots of, I think, paper in the past recent years also published and discussed about the ultra-high fiber count cable. But very brief, this introduction and description. Basically, with increasing optical fiber demand and limited ducted space, the fiber optic cable industry tried to respond it with a higher and higher fiber density cable. Really, since the first introduction of this very high fiber density cable designed for small ducts, deployment and installation of this cable become more routine, and it is obviously desired for compatibility with mass fusion splicing to reduce the installation time, which is one of the crucial points. There are basically two ways to go. Use a high fiber count cable using the basically small micro module with the loose fibers, or going which splicing, or they basically time consuming. Another way, or use the basically flat ribbons or conventional ribbons that splicing is not an issue, but getting to the high fiber count cable is the main issue. So for encapsulated really ribbon or conventional ribbon, the structures remain relatively stiff and difficult to configure into high packing density within the tube. Even if very low modulus material is used for this application, material tend to also have a high coefficient of friction, which can induce stresses and marker strain within the ribbon stacks in the finished cables. So basically the solution that the industry introduces is based on the keeping the fiber in the proper orientation for mass fusion splicing with really intermittent bonding, and the really various approach achieve or introduce into the industry. And these new designs, they have the advantage in flexibility into the cable and mass fusion splicing. So I'm going to basically going through the one of the application basically for the development of high fiber count cable is and one of the reasons for the development of high fiber count cable is the growth of the data center with the progress of clouding computing, and it is really necessary to process enormous amount of information, and it's really urgent to develop data centers and optical communication network. So the demand for high fiber count and high density optical cable increases dramatically, and it goes as high as like 3, 4, 5, 6, 6, 9, 12 fiber count cable, etc., which is developed very initially for Japan's fiber to the home network, where fiber density and small cable size becomes an important and crucial factor. As you said, more than 25,000+ fiber coming into each building with above 50,000 servers plus per building. So therefore, it's basically it's necessary to accommodate optical fiber cable in the existing duct and the spaces for the installation. Last year, we announced our new FlexRibbon technology and ultra high fiber count cable, which is basically also seeing this application. I'm going to discuss about the current rollable design. Some existing fiber cable manufacturers have developed a partially bonded optical fiber ribbon, which also referred to as the rollable ribbon, where the optical fibers forming the ribbons are not bonded or encapsulated over their entire length. So basically they are used to increase the fiber density in a cable and reduce the cable diameter as mentioned. And there are various designs to achieve the rollable ribbons, allowing the fiber optic to be folded or rolled into an approximately cylindrical shape to better feeling of the better feeling of the circular cable, and it is resulting in more optical fibers to be included in a given cable diameter compared to optical fiber with traditional one. I mean, the main goal is really to double the fiber count capacity in the same cable diameter with the, as I said, advantage of using its mass fusion splicing. And I think essentially the main challenge is the mass fusion splicing with the as high as possible flexibility of this fiber in a ribbon shape in a cable. Really traditional ribbon are packed into a round shape buffer tubes or whatever design that we're talking about. And due to this stiffness and really, I would say rigid, the unique structure of the ribbon itself, the round shape of the tube is necessary and cannot be really altered. So therefore, the formation of the tube causes EFL, attenuation issues, and failure during temperature cycling and so on, and aging. But by using the FlexRibbon and this kind of new design ribbon, a random distribution of ribbon, give us in the buffer tube, give us the good flexibility together with the good attenuation performance at low temperature. All right, so I'm going to go through the new FlexRibbon design technology that basically Prysmian came up with. In FlexRibbon design, the individual fibers are bonded in a correct sequence. The pattern adhesive beads such that in any case, in any cross section across the ribbon, only two adjacent fibers are connected at one time. So this bonding pattern results in a very flexible and robust ribbon structure, which is compatible with mass fusion splicing. And the entire structure is evaluated for robustness, splice compatibility, as well as attenuation performance for the long-term aging and environmental exposure. As we have recently announced our high fiber count cable, we are about to have we have advantage of using a FlexRibbon in conventional cable design by doubling the number of the fiber count and more with the same cable OD. And also in this slide, there is basically into that is showing the evolution of the high density cable, which is the historical evolution of the high fiber count density cable from marker module design, which is not designed for mass fusion splicing, to high fiber count cable ribbon in loose tube, which is mass fusion splicing compatible. And this is obtained by using Prysmian FlexRibbon product. I'm going to the new cable design. Our basically on this, our attempt was to have the maximum flexibility for the number of bonds in any cross section instead of having a multiple bond, which is resulting really to the optimum flexibility. This bonding pattern, more than having a very good flexibility, is robust enough structure that basically is not causing any issue during the mass fusion splicing, or the ribbons are not falling apart, or are not causing any like a disaster problems during the mass fusion splicing, which is a very important parameters for this kind of ribbon structure. Moreover, due to the flexibility of the ribbon, reshaping of the tubes also was possible in this cable structure, which is an optimal solution for protection of the ribbon, specifically in a buffer tube by using the ribbon in loose tube structure. And for each unit, there is an easiness for identification of the ribbon. So when the tube get into the enclosures and for routing and all kind of things, it is much better to identify the ribbons and without having a lot of mess around the working table. So ribbons are better organized for the installers, that it gives a better opportunity and better easiness to install splice the ribbons. So as I said, unlike the conventional ribbon that generally maintains its shape with the fiber laying on the straight plane, this new ribbon freely changes its shape and providing the highest fiber density with reduced attenuation, as well as residual strain in the cable, free of the strain and the stress that you are not affecting the attenuation performance of the cable. The challenge, really, ribbon should be able to move freely relative to one another as they are adjacent together in the finished cable, so that stress do not develop in the ribbon stacks as the cable is bent. And for the ribbons to move freely, the ribbon basically must have also relatively low coefficient of friction. And because of the also reduced bonding area, the traditional encapsulated ribbon material are not really, not optimized for this application, and modification of ribbon bonding material was required. Although the adhesive material has a slightly higher coefficient of friction relative to traditional encapsulated ribbon matrix, the final pattern ribbon structure has a coefficient of friction than the traditional encapsulated ribbon, which really help movement of the fiber within the cable structure. And then on this, I'm going to go to mass fusion splicing, which is the very important parameter that I'm going to cover here. So we believe for this kind of ribbon structure for this kind of ribbon, really the flexibility on the opposite side of the mass fusion splicing. I think, in my opinion, we did actually for this reason a lot of number of trials to increase the flexibility and also optimize the mass fusion splicing. The things that the mass fusion compatibility spliceability of FlexRibbon, we evaluated and we came up with the best as possible optimal mass fusion splicing, and with increasing ribbon flexibility by increasing the basically by changing the design, it allow us to have the best splicing time. As it is shown in the figure, we carried out several experiments by different people that showing that the average splicing time actually for the standard encapsulated ribbon was, as far as everyone probably knows, it's about 1 to 2 minutes. This is done by the lab technicians, and I think there's a good agreement on that. And for the shortest splicing time and ribbon flexibility, when basically obtained when we came up with the FlexRibbon, and we can say for available or commercially available spide of a ribbon or the rollable ribbon, they are in the same range of variability as it is available commercially. So it was roughly the splicing time higher than the standard ribbon, but the availables ribbons are in the same range of variabilities. This is about the 250 microns, and in regards to 200 microns, what I'm showing here, these are the first experimental splicing data that we recorded for the first splice on 200 micron. Obviously, this depends on the end user's requirement, and there are also a lot of improvement being made by mass fusion splicer companies in the recent year to reduce the time to splice for this kind of ribbon, and is getting more and more attention to the industry. So on the 200 to 250 micron mass fusion splicing, also, as I said, there are solutions out there, and we can. Our FlexRibbon is also capable of splicing the 200 to 250. So this splicing thing is getting, I think, more attention with the splicing company, and I think there are a lot of work has been done by these companies on that. And then also we have identified we are a couple of the accessories for 200 and 250 micron for splicing of the FlexRibbon. On the robustness and really mechanical handling of the ribbon, which is actually another important point, we found the critical parameter to really ensure that the bonding material holding the fiber. Therefore, we check the positioning of the bonding material for our internal qualification testing, and also we developed the machine, we call it the ribbon robustness technique, to evaluate the robustness of our ribbon during the cable processing to ensure that the ribbon met the requirement to the cabling and installation and splicing. The FlexRibbon ribbon in loose tube, in this example, 1728 fiber count cable, are basically the FlexRibbon, as we said, is rolled up into compact fiber subunits for easier routing. And this results really into a significantly smaller diameter and lighter weight cable, allow for easier installation and the use of smaller ducts. As I said, these are the main tests that are carried out on the cable, but these are the test methods that are not determining the criteria for pass or failure. But our cable met the requirement for GR20 for this test method, and the cable tested was an dielectric 1728 fiber count cable ribbon in loose tube, designed for using outside plant and complying obviously with the requirement of GR20 core where applicable, and it's also watertight and to meet the requirement of GR20 core. So I'll go ahead, and these are basically a picture that is showing that our cable installed in hyperscale data center, and is showing the pictures that installation and splicing was completely successful. In terms of basically qualification of the test results, I would say really if coating ink or adhesive material not optimized in ribbon products. Exposure to water can cause adhesive interface failure in the ribbon during long-term exposure to water. These adhesive failure are typically periodic and can create or sometimes micro-bending attenuation during the water soak testing. And so an image showing of non-optimized ribbon coating system after water soak is given as an example, which is the evidence of this mode of material failure. But our ribbon is optimized, so we haven't noticed any issue like that historically, and we checked all the data. Attenuation also was monitored during the water soak testing. Exposure to 60 degrees C for a long-term period. Actually, it is showing for 30, but we have also the images showing the data attenuation at 125 days for the flexible ribbon. Attenuation change was really at the noise level for all the fibers during the course of the test, and we haven't noticed any evidence of a delamination in any component of the coating or ribbon adhesive system where we inspected in fiber after water soak testing, which is one of the perfect things that we noticed about this cable. And this is, as I said, this is the longer test aging for extended period of time after the water soak, and actually attenuation measured during the water soak testing, and is showing that the data are remaining in the noise level without any significant change. And there are a couple of variable investigating materials that have been also tested with the same behavior. And regarding the ribbon robustness, again, we have a really called test method that was ribbon robustness was measured by using a T-pill geometry to basically measure the separation force of individual fibers from unaged ribbon and ribbon aged after environmental exposure. We have noticed a little change in ribbon robustness after aging, and the ribbon could be easily handled, and we inspected without breaking of any bonds, even after environmental exposure. And the T-pill separation force for individual fibers from the ribbon for unaged fiber and fiber age also is showing in this histogram that you can we can see the result after the aging. And this is also another experimental testing that is showing for in the case of a 200 micron fiber. Okay, I'm going to wrap it up and probably talk through the conclusion, and then I'm going to get more questions or any question if it's raised up. So in conclusion, basically we have described in this paper, actually these two papers, ultra high fiber count cable using FlexRibbon, which is environmentally robust and structurally robust, and the ribbon structure has been optimized and manufactured with the ideal mass fusion splicing procedures, as well as the highest packing density in the ribbon in loose tube design. The cable was tested using industry standard test method and is accordance with the GR20 core, and also the basically the 1720 ribbon in loose tube cable design incorporating FlexRibbon is basically introducing these two papers are meeting industry standard tests, as I said, for mechanical and environmental performance. And this cable that we present also was successfully deployed in the hyperscale data center application. I think this is the outcome of the great work of the such a great people that I'm always thankful and appreciate all of you for listening to this presentation. And I'm taking questions if there is any.
Thank you, Ehsan. So yes, at this time we will take as many questions from the attendees as time permits. Starting with this first question. For ultra high fiber count cable designs, what do you see as the minimum number of ribbons or fibers possible for these cloud or FTTH applications?
I think for the minimum fiber count, I think, I mean, as we said, the highest fiber count cable goes up to 6,912, and I think it's going higher and higher. But I think I'm thinking might be as high as 3, 4, 5, 6 or above. That's the and 1728 or above. That's the more reasonable thing. So.
Okay, thank you. Are the bonding adhesives of the ribbons widely available, or are they consumed, or excuse me, are they custom or proprietary?
I'm not sure I get the question exactly.
Okay, I'll reread it. Are the bonding adhesives of the ribbons widely available, or are they custom or proprietary? This is.
Yeah, I think this is the things is more. I think it's not a place to discuss about. I can discuss offline if anybody interested can email me. But it's more proprietary answer. It's going to be whatever I tell you. So we can. I mean, you have my contact number and information. You can contact me, and we can probably come back to you with the answer.
Okay, that's it. Very good. Thank you, Ehsan. Next question. Have the installers embraced the rollable ribbon designs, considering the customized and increased time of splicing?
I think the feedback was very, very positive on this ribbon that we had, and I personally witnessed installation of this ribbon, and I think what we have right now is the optimized ribbon for mass fusion splicing, and the time that we are achieving for splicing is really close to conventional ribbon. So I believe since the ribbon that we have right now is mechanically robust and we don't have an issue of putting any glue or problem of disbonding or kind of things. This is really good for installers that they were happy with it in terms of the time to splicing.
Okay, thank you. Next, has ribbon robustness been a problem in conventional ribbon designs? In other words, have rollable ribbons provided better solutions to meet demands of cabling, installation, and splicing?
No, I don't think that it does have. I think the flat ribbon, conventional ribbon, is robust enough and it's very good in terms of the structure. I think it's two different things in terms of first of all, application, and then high fiber count application. and using this rollable ribbon or FlexRibbon or all kind of things in the high fiber count is demanding a high, basically, robustness that people don't want to be facing when they open up the cable, seeing ribbons are not in good shape. So they want a ribbon, but they want also good compact density or packing density in a cable. Therefore, it's not criticized of the robustness of the standard or conventional ribbon. That's I think the different things.
Thank you. Next question. Can this cable be used in an aerial application and lashed to a messenger wire?
Yeah, I think if it's required, I think that I'm not familiar with the application, but is the dielectric cable, and I think it can be also implemented if the criteria for the application meet. I think it can be.
Thank you. Next. How much was the change in attenuation in thermal cycling test?
In the, I think again we can, if there is this kind of question, it would really probably I'll take it up offline, and if specifically considering a certain fiber count cable, we can discuss, but information also provided in the paper that can be found, and if additional question needed on that, we can come back to the people.
Okay, very good. Thank you. Next, how many fibers were tested during environmental testing?
I think, we test all the fibers, and we don't have an issue with not testing them. So we test all the fibers during the environmental testing. So we always check all of them to be sure that everything meets our requirement, our customer requirement for testing.
Okay, thank you. When will 6912F be commercially available? Are there any counts Prysmian is looking towards between 3456F and 6912F?
I think we announced a couple of months ago publicly presence of highest fiber count cable officially, and I think that's everything officially available right now, and we announced our existing highest fiber count cable, especially 6912 cable. So everything is on the public domain.
Okay. Next, what is the attenuation penalty for a flex ribbon cable versus a more traditional ribbon cable?
I think, as I said, we can discuss these things offline, but I think we are meeting the basically GR20 standard requirement, and this is what we also reported in the paper for 1728 and ribbon and loose tube. And if there is any doubt or any question about the or curiosity about the other fiber count cable, you can send us a note to my email, and we will definitely consider to answering it every specific cable.
Okay, thank you. Next, The flex ribbon has a very special shape. Can it be produced with reasonable speeds, such as 500 per minute or more?
I think another way of asking what the speed you are running it. I think, but is I think a proprietary of my company, and I cannot release this information. But so if I can again consider any question like that by the email and come back to the people by the answer.
Sure. What is mainly different between FlexRibbon and rollable ribbon in spite of structure?
I mean, there are different, as I said, different way of doing this ribbon structure as fiber optic manufacturing companies came up with, and our FlexRibbon structure is a completely different pattern, has in a way that basically our ribbon is more flexible, and at every cross section we have only one bond that keep the ribbon in place, and basically compared to other existing ribbon or rollable ribbons that they have a multiple bond at every cross section. Our ribbon has an advantage because we don't have the resistance or all multiple bond at the same cross section. So this gives us the much better flexibility as well as the mass fusion splicing performance.
Okay. Next, was there any increase in cable prep time compared to conventional ribbon cable of similar fiber counts?
I'm sorry, can you repeat again?
Yes. Was there any increase in cable prep time compared to the conventional ribbon cable of similar fiber counts?
Oh, no, actually, the preparation time is really, I think, is very, very similar to the conventional ribbon, especially we are using the conventional ribbon in loose tube design. And as I introduced, because of when we get into the enclosure, we are protecting the ribbon by buffer tube, so the routing is much easier, and we are not damaging our ribbon during the exposure, during the installation, that people or installer are not facing all the ribbon on the table. So is one by one the tubes comes in and then routing the ribbons into the trays and then get organized and then spliced. That's the basically exact things that people doing with our conventional ribbon. The time to splice for the flex ribbon, as I mentioned in one of my slides, is a little bit higher than the conventional ribbon, but this is the case that really all the rollable ribbon structure are having it. But there's also the point that people are getting used to rollable ribbon and flex ribbon structure. They can do faster and faster, and I think that industry is adopting that as the really common practice in the standards and during the installation. So the answer is no. I don't believe that the installation time is higher. I think that's pretty much similar.
Okay, so I would take one last question before. What is your max length availability on 1728 fiber constructions?
Max length of the cable, I think I can double check that. but I think we are able to do like up to 3 kilometer on the rail. But we can double check. That's the. I mean, we can send me an email and I can answer that. I'm not pretty sure on that.
Okay, thank you very much.
Thank you.
Ehsan, thank you very much for presenting this very interesting and important topic today. Please note the contact points being shown should you wish to contact Ehsan after today's event. Each of these IWCS webinar series presentation events are recorded and will be archived on the IWCS.org website. It normally takes up to 2 weeks for these to be posted. The IWCS webinar series will conduct presentation events on a monthly basis. Webinar events will take place on the third Friday of each month at 10:30 a.m. Eastern USA time. Our next scheduled webinar event will be on Friday, March 15th at 10:30 a.m. Eastern USA time. Each of you will be receiving an announcement for the event a few weeks prior. Please feel free to share our announcements with your colleagues so that they can join in and register as well. For over 67 years, the IWCS International Cable and Connectivity Symposium has been the recognized leader showcasing new technologies in cable and connectivity products, processes, and applications. Our next annual international conference will take place on Sunday, September 29th through Wednesday, October 2nd, 2019, at the Charlotte Convention Center in Charlotte, North Carolina, USA. In addition, the third annual UL and IWCS China Cable and Connectivity Symposium will take place on Monday, March 25th through Wednesday, March 27th, 2019, at the Marriott Hotel City Center in Shanghai, China. Please visit our website at iwcs.org for more event details. In just a moment, you will see a brief survey so that you can provide us your feedback and comments on today's event so that we can further improve this webinar series for you. Thank you for participating, and this concludes today's event.